Welcome to today's video on electromagnetic radiation, part 2. In part 1, we learned about light behaving as a wave, and in part 2, we're going to look at light behaving as a stream of photons. And a photon is a little packet of energy, a little packet of light energy. And so the thing that we want to remember about electromagnetic radiation is that light travels as both a wave and a particle at the same time, but when we observe it, it kind of picks which way it's going to behave. It's really quite strange, but this is the nature of quantum mechanics. So today we're going to focus on the particle nature of light. Again, we said light is a particle. This will help us explain why only certain frequencies of light are observed when something is heated, and also that matter can lose or gain energy in small specific amounts. We are going to observe this later on this week and next week in labs that we'll do. So we won't go into too many specifics here, but matter can only gain or lose energy in specific amounts. And so again, we call this the wave-particle duality of light. If you're interested, you can check out this YouTube video on the wave-particle duality of light for maybe a little bit better understanding of how those two are related. But today we'll focus our attention on an equation that relates energy and frequency. So energy and frequency are directly related here. The higher the energy, the higher the frequency. And each frequency of light will carry a specific amount of energy with it. And so that's defined for us by this equation. E is energy of a photon. And so it's the energy in joules of a photon, which is a light particle. H, this is different than wavelengths. H is Planck's constant, named after Max Planck, who helped put this relationship together. His constant is here, 6.626 times 10 to the negative 34 joules times seconds. And then the last letter, nu, of course we know is frequency, and the units for frequency are hertz, or seconds to the negative 1 power. This equation will be super important, so we will want to highlight this one and make sure that we know what each of the letters means and represents. Okay? So let's do an example. A photon has an energy of 2.93 times 10 to the negative 25th joules. What is its frequency? And then we'll identify the type of radiation. Okay, one thing that I'll want to do first here is to mark my text. I can underline the things that I know. A photon has an energy of 2.93 times 10 to the negative 25th joules. So that's E up here for energy. The thing that I don't know is frequency. What is its frequency? I don't know the frequency. So if I go back to my previous equation, I know that E equals H times frequency. I have an E in the problem. I don't know frequency. So H, remember, is that constant, Planck's constant. If frequency is what I'm solving for, let's get frequency by itself in this equation. So frequency will equal E over H. Now I'm going to plug in my values from what I know. So my energy was 2.93 times 10 to the negative 34, and I'm going to write the unit joules there. Divide that by Planck's constant, which was 6.626 times 10 to the negative 34 joules times seconds. So when I divide these two, oh, my apologies. This is supposed to be a 25. Negative 25. My apologies. I was jumping ahead with Planck's constant there. So 2.93 times 10 to the negative 25 divided by 6.626 times 10 to the negative 34. So if I punch those into my calculator correctly, and I'll know when I'm punching my numbers into my calculator correctly because I'll be using the EE button, remember, or the EXP button in my calculator to say times 10. All right, when I do that, I should come out with 4.42 times 10 to the 8th. And let's just double check if that really is to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 7, 8. Yep, to the 8th. So 4.42 times 10 to the 8th. Okay, now the question becomes what units go on here. And a lot of people ask about that. So notice in your equation that joules is going to cancel out and seconds is left in the denominator. So this is like 1 over seconds, right? Well, another way to write that then, instead of 1 over seconds, is hertz. We saw that unit before. And that makes sense also because I was solving up here for a frequency. Okay, so this is my unit, or this is my answer when I'm solving for frequency. If I were to find the type of radiation, I would need an electromagnetic radiation spectrum to do that. So I'll jump ahead, write this number down, I'll jump ahead to the next slide here. And so my spectrum was, or my frequency, sorry, was 4.42 times 10 to the 8th hertz. And so I'm going to look right up here where frequency is to find where about 10 to the 8th is. And it looks like it's probably going to be somewhere in the FM radio range. Okay, that's how I would tell the type of frequency for that. Okay, do some practice problems on your own. Let me know what questions we have in class, and thanks for watching this video.